Good morning, everyone.
Morning.
That wasn't horrible. That was pretty good because it's early in the morning. So, everybody, so what I'm going to do right now is I'm going to attempt in 90 minutes to debunk a lot of the different CO2, not from an engineering perspective, not from a sales and retail perspective, but things that I hear from technicians, calls I've been on. So that's kind of my goal here. So, you guys are ready, right?
Yeah.
Give me fuel, give me fire, give me that which I desire.
I want to set expectations. Are we good? So that tells us, look, I'm going to go through this. I got slides. 9 times out of 10, I never make my time. I always have too many slides. That was rude. But what I want to do is, these things don't, I put this presentation together and it's awesome. I am so awesome when I put this together. But the problem may be that it doesn't meet your needs, or you have a myth that I don't have. So what I'd like to do is simply make this a conversation between a small little intimate gathering, yes? Everybody good?
Yep.
So if you got a question, you disagree with what I say, I don't care. Come on, let's talk about it. Is that good? Let's just have an open and honest conversation. And if you don't agree with me, well, that's okay. But if we can't come to a resolution, we'll just take it outside. Of course, people out there, I'm not going out there. But we got to solve these issues. So as I go through, if you want to have a conversation about, and I'm adding one that came to me in my sleep that I'm going to add towards the end if I have time. Because this is the big thing when we start talking about 90 bar and people start talking about relieving gas and mechanics. So I'll tell you this. And a lot of you guys, how many of you guys have worked on a CO2 booster system or CO2 secondary system or a cascade system? So those of you who have worked on them, when I say certain things, don't sit there and go, yeah, I'm a liar. Let's talk about it. Amen? Amen?
Amen.
Because that's what you want to do. So I hear a lot of people. I was on a call about a month ago, and I'm listening, and the dude, the service manager, tells me, he says, yeah, my mechanic was there, pumped the rack down, and lost all the charge in 40 minutes. My BS meter started to pay, because there's no way. That didn't happen. But here's the thing. As I go through this, keep this in mind. And I'm going to hurt some people's feelings, I'm sure. But a lot of this stuff, like if I make a mistake and I'm working on a CO2 rack, was it my fault? Was it my fault? No, when I write up the ticket?
Never.
It wasn't my fault. That damn CO2, what are you going to do with it? Right? So some of these myths are things I hear where people blame some of the CO2 when it really isn't CO2. Are we good on that? How many of you got just got butter? Anybody? Nobody? Because it's not you that does that, it's the other guy. Right? So here we go. All right, so this is a standard small booster rack, right? And one thing you'll never hear me call this is a transcritical rack, but it is a booster rack. Just shows you it is a small rack. Matter of fact, what does that look like? There's some scroll compressors, a couple of Bitzer compressors, a couple of breakers. It simply looks like a what? If you didn't know it was CO2, would you know it was CO2?
Oh, 44.
Stop it. But, oh, this is going to be a quiet class. But if you look at this rack, the one thing we want to understand, at the end of the day, this is just a refrigeration rack. There are some nuances that I have to understand, but at the end of the day, this is just a regular refrigeration rack with superheat, subcooling, and all the things that I expect to see on a regular CO2 rack. And I'll call, one of the things we have to remember when we go to these racks. I saw this out here in California. I think it was at a grocery outlet. I love this. This is a service manager put this on a rack. Because I'm assuming a couple of his technicians, just because you see 1,100 pounds of head pressure, you start getting a little nervous. It's okay. We designed the systems that way. Alright? One of the things I hear a lot is it's just too complicated. Anybody ever heard that or seen that or thought about that when you walk on the rack? I hear this all the time. It's not. What you have to do is you have to do your due diligence. You have to understand there's a couple of valves that we might cover a little bit. And I know Paul's going to cover some of them in detail later today after this class. But once I understand those, the high pressure control valve, the flash gas bypass valve, doesn't matter the manufacturer. They're all basically the same piece of equipment, right? We're all using the same equipment. Copeland has just come up with their new CO2 reset. So everybody's in the part, so it's not that complicated. It simply looks like a simple rack. It's got compressors. Now, booster, a lot of people think the booster part of it is weird. Everybody know what I'm saying when I say booster? Everybody understand that? If you don't, raise your hand. Booster simply means that I'm taking the medium temp or the low temp discharge and I'm boosting it or dumping it or putting it into the medium temp suction as load. So the low temp will simply be load to the medium temp compressors. Is everybody good with that? Has anybody ever heard of that before? Where you take a suction and put it into another set, let's say pistons? Anybody ever work on a Carlisle two-stage compressor? Is that not booster's configuration? Are we not doing it to lower compression ratio? So it's not that complicated. We've been doing it. If you're an ammonia guy, this is straight out of the ammonia handbook. All right? So the only thing that makes this different is some of the vocabulary. You know, once I understand subcritical fluid or supercritical fluid, that's what a lot of people call transcritical. All right? One thing about booster racks or CO2 racks, or let's just change that. Let's change that to CO2 as a gas. Is everybody with me? CO2 as a gas has a very low critical point. A critical point simply means that the CO2's critical point means is at 87 degrees, and at 87 degrees, this gas changes its density. That's all it means. Nothing complicated. It goes from a two-phase fluid, liquid vapor, like in my condenser, and it becomes a single-phase fluid. Are we good? Why? Because the densities have changed because of the characteristics of the gas. So I don't have to, as a mechanic, I don't have to understand that. All I have to know is when I get above 87, I can no longer condense my CO2. I don't care how many sprinklers, stop doing it by the way. Those of you who have transcritical rack and put sprinklers underneath it, because you think you're condensing it, all you're doing is shortening the life of the condenser. So stop that. All right? But I just have to have a different way to condense it. As a mechanic, all I have to know is that my fans are going to be on, and I have to make sure my high pressure control valve works. And I'm going to go through that. Paul's going to go through that, and I'm going to do that on my troubleshooting part. How do I get this to work? What is it doing? It's dropping the pressure, but it's changing the state of my gas from this super weird, supercritical single phase fluid into a liquid vapor mixture into my receiver. All right? So it's not that complex. I have a valve that changes the state of the gas. Wait a minute. I have a valve that changes the state. Can I draw? I love to draw. Oh, it's a Sharpie, damn. All right, so let's look at CO2, this supercritical thing, what I'm talking about. Maybe easier if I draw it up. So this is CO2, my enthalpy chart. There's my pressure, there's my enthalpy, right? This is subcooled liquid, this is superheated vapor, this is my compression, this is my expansion valve. But once I go above this 87 degrees, yes? And I'm coming here, it's 104 on the roof, yay! I come up here, I discharge out of the medium temp, I come up here, above this number. That simply means the gas has changed. The characteristics of the gas have changed. It's no longer a superheated vapor. It's no longer, I can't cool it no matter how big my condenser, not my condenser, my
Superheater.
no.
Gas
He was just seeing if any of you would catch that. Because if there's no superheater, it's no desuperheater, say what? Okay, I was expecting somebody here to get a gas cooler, but I guess I'm gonna have to do all the work myself. Alright, so now my condenser becomes a gas cooler because I simply cannot condense the gas, yes? We said that. Once it's above there, it's this new thing. It's a single phase fluid. I can run my fans all day. As a mechanic, all I gotta make sure is my fans are what? Running wide open. So I'm gonna make so now I can't send this 1,100 pound gas into my store. So I have to understand how this works. So as a mechanic, I just have to know this valve, this high pressure control valve, whatever configuration that is, whatever manufacturers, Portland, Danfoss, doesn't matter, CCMP. I just have to make sure this valve creates a pressure drop. And as long as I know that, it's easy to work on. So where are my mechanics, my everyday hard mechanics? I'm gonna ask y'all, I ask everybody a question. So I have a valve right here. Yes? That's what you say, yes? And I'm coming through there out of the gas cooler. I enter this valve in one state, supercritical. I come out of that valve. I've dropped the pressure. I'm back here, so now I'm saturated, which means I'm a liquid vapor. Yes? Has anybody ever heard of a valve that you enter the gas at one place? It's in one state when you enter this valve, goes through this orifice of this valve, then changes the state and lowers the pressure. What is it? Carburetor. There's always one I gotta kick out of class. When David's done, he's gonna come at. All right. No. What is it?
Metering device.
Metering device. A TXC, is it not? And if you look at it as such, I've been working on TXPs for a while. I've understood them for the last 6 months. But, so is that complicated? Don't you know how that works? It's just electronic-ish. If you think about operationally. Yeah, there's some nuances. I have to understand percent open. I have to understand where it gets its signal. Damn, dude, we gotta start all over.
Cool.
But I just want you to understand, in different modes, and Paul's gonna go through this, sometimes it's acting as a holdback valve. All I have to understand is what does it do in what condition, and it's a no-brainer. I gotta know what the inputs are, no-brainer. It's a very simple, and guys overthink how this valve works, and that is one of the reasons. That's one of the reasons it gets this reputation as being overcomplicated. Transcritical cycle, you'll rarely hear me call these racks. How many people have heard these racks called transcritical? Rack. We're working on a transcritical rack. You'll rarely hear me call them a transcritical rack. I'll call them a booster rack, because that's the technology. So those who've heard it called a transcritical rack. That's how it's starting from. My man is helping me out here. We'll put him on the payroll. Carburetor. It transitions from subcritical, which is what every system we have working, and it transitions into a supercritical gas. Are we good? As the ambient temperature goes up, it becomes this new thing, right? What the hell was I saying? Oh. And so that only happens when it gets above 87 degrees. But when it's below 87, this rack operates like any other rack you've ever heard. You got a condenser, you got fans that have to cycle, and so this rack is a standard rack. It just transitions into this supercritical rack only after 87 degrees. Is everybody with that? So the reason I don't call it a transcritical rack is it's 40 degrees outside. This is just a regular, we gotta quit making it harder. It's just a regular rack. At 40 degrees, at 60 degrees, at 70 degrees. When I'm working on that rack is nothing more than a refrigeration rack. Is everybody with me? And we don't need, what happens is we say, oh my God, it's transcritical. No, it's just a different state that's gonna run onto, and I'm gonna handle it when I go through that valve. And the inside of my store never changes. My cases, they have no idea if it's supercritical, if it's subcritical, if it's 80 degrees out, or if it's 30 degrees out. Because I'm handling that when I drop the pressure through that high pressure control valve on my 100 degrees, and I drop that pressure into the receiver or flash tank. Are we good so far? I can see some of you are going, what the heck? So I'm also available after class. All right, critical point. It's where the gas can no longer be condensed, right? And CO2 is one of, many gases do that. CO2 is the only real refrigerant that we're using that condenses. That's where I'm going to see it run at a higher pressure. But remember, it eliminates the distinction between two phases. It's a single phase fluid. That's all it is. All right? And all refrigerants have a critical point. If I look at ammonia, 404, 448, they all have critical points. The only difference between that and CO2 is ammonia is not going to go transcritical. Unless, of course, the ambient gets to 270, and then that whole code warning thing was really a thing, right? And I'll be living underground as a gopher if that happens. So just understand, even 404 at 160 degrees becomes supercritical. And CO2 is very low. All right? This shows my subcritical operation. These are the kind of things that make this look complicated, because people read about this and hear about this, but understand that when I'm subcritical, I'm just managing subcooling, and Paul's going to cover a lot of that. All right. So I'm going to go through this. I'll come back to this maybe, because you like that one better? Oops. This is something that a lot of people, I get a lot of calls on. How many people know what that is? How did we create dry ice? Drop the temperature or drop the pressure? Pressure to what? 60 pounds gauge. So anytime I'm servicing this case, if I'm opening the case up, if I have a big enough leak, what I can do is allow the pressure to drop below 60. And remember, it's only the liquid. So when I service this case, as long as I keep the liquid above 60, I cannot create dry ice. Everybody good with this? And so when I'm venting the case, if I'm servicing this case, and I begin to start venting, I'm changing an expansion valve or the dryer in a case, and I pumped it out as best I can. And I go, and I gotta get this case. I pumped it out as best I can. I close the liquid valve. I think I have all the liquid out of there. But I don't know for sure. So the best thing I can do is put my set of gauges on it. Is everybody with me? I'm on a case, I'm changing the liquid dryer. I've got to open this case up so I can cut the dryer out. But if I open the case up and there's still liquid in there, and I let that liquid hit the 60 pounds, that liquid's going to change to, and now I have a what in my line? A restriction. Yes? So, and I'm going to have to wait, and I'm going to have to add vapor to get it to sublimate, to change state. So what I want to do here is I simply put my gauges on it, and I begin to vent the gas. I feel so good when I say vent. Yes? Because it's been a long time. You know, I started in R12, and it's a long time since Believe it or not, I actually have young mechanics who are working, and I say, dude, vent the gas. What do you mean? Open the gauge. And let the gas out? Yeah, vent it. But don't I need a reclaim? Kid, let the gas out. You'll feel cleansed when you do it, right? Because it's for us old dudes, man, do this back when we were cleaning conduction with R12. Sorry, I didn't mean to say that. But yeah, so I simply vent the gas out until I hit 100 pounds. Yes? Because I don't know if I got rid of the liquid. I think I did. I tried to, but I'm not sure. So I don't want to vent the gas all the way, because if there is liquid, it will turn into dry ice. So I simply crack my valve, and I track it. Just crack it. When I hit the 100 PSI, I do what? Close it. If there's still liquid in that circuit, what's the pressure going to do? It's going to go up. I know there's liquid in there. I do what? I vent it back down and stop where? I stop at 100. I continue to do this until once I stop at 100, what happens? Nothing happens. Stays right where it's at. Now I know all the liquid's gone. Now I open my hose and I vent the rest of the gas. Cut my valve out, pull a vacuum. After I put it all together, I pull a vacuum. So I get my vacuum pump out of the truck, and I pull a vacuum, change the oil for those who don't know. Pull a vacuum. I always say a three cigarette vacuum is good. I guess that'd be one big pot. I haven't timed it yet. Simply pull your vacuum, and then once I'm in a vacuum, then I run over here to the liquid line, and I open the liquid line. Yes? No, because what did I just create? Dry ice. So I simply crack. It's superheated vapor on the suction. Yes? Oh, did I forget to close the suction valve earlier? My bad. Before I started venting, make sure you close the suction. I'm in a hurry. I got 3 calls holding. I gotta go. Simply close the liquid lock, the suction line, before you vent. Yes, is everybody good? And then once you do that, pull the vacuum, put vapor in it. I'm at open liquid. I'm ready to go. Amen. Not that hard. I just have to understand the process. I have to understand the process, what it is. I get CO2. So how many of you are on the supermarket tech talk? Actually, I have one of the stars of that page with me. But if you watch it, you see a lot of things about dry ice that are not true. I get a guy from Walmart call me. He said, dude, I have a problem with some dry ice in my system. I said, really? What's going on? He said, the dry ice is getting to my expansion valve, and then by the time we get there, it melts, it goes to another case. And then it melts, it goes to another case. I said, dude, what's the pressure of the CO2? He said, well, it's 200 pounds. Yeah. Does he have a dry ice problem? No. Can dry ice exist at 200 pounds? Not at all. He does. He said, I said, well, what's your solution? He said, I'm going to vent the gas out and pull a vacuum. To which I said, sounds like a great idea. Yes? Because what was his problem? His problem wasn't dry ice, it was moisture. Moisture. But it's CO2, dude. It's got to be dry ice. No. Look, I know dry ice. I'm the first person in North America to turn an entire receiver into dry ice. So I know what I'm talking about. Don't do that, by the way. Not cool. Not cool. Product will get warm. Luckily it was in the lab, so I was good. Where's the thing? Kibitzers. All right, so just remember that about CO2. And if you do create CO2, no big deal. Just simply put vapor on it, and it'll change state back into liquid. So it's not that big a deal. Uh-oh.
Can you put those on it?
Sir?
Can you put those on it? Can you put those on it?
Saza?
No, those on.
I don't know what that is.
Good. You
See?
put that?
This is what happens when you forget your hearing aids.
Those on? Those on? It's like little chemical you put in the refrigerator, keep freezing it inside the refrigerator. Years ago.
Yeah, no, we're not doing that.
What the hell do we-
I'm like, I'm gonna have to look that up. What the hell is that? All right. Oh, one thing I will warn you about, especially young guys, when you start venting inside the store, that even sounds bad, does it not?
Yes.
So, and it looks like smoke coming out of your hose. So when you're in a store, be cool. Simply, what I do is I just put a recovery rag over the edge of my hose, and I vent into a recovery rag. That's what I tell them when they ask me. Don't, I have guys go, hey, I'm gonna put it in water. Guys are gonna vent into water. You ever seen that? You know what happens? Next thing you know, they think Gene Simmons is coming out with case. They create a ball. It looks like we're fixing to have a rock concert. So don't do that. Simply vent it into a rag. Be cool. Keep in mind, they have no idea what you're doing. And I'm looking around the room, and I can tell that whatever the hell you're doing is bad. So be extra vigilant when you're doing that. And again, I just went through this case. Sublimation. How many people remember that from high school? Sublimation. We go from a solid to a what?
Yes.
Without passing the liquid state. Could that be a problem? Let me tell you that happened. I saw some key mechanical guys running around. I got a call from Key Mechanical a couple years ago. Dude called me and said, hey man, you might want to be interested in that. I said, what happened? He said, we got a leak in the cooler. Really? Okay, well, what happened? Well, we looked for the leak, couldn't find it. We couldn't find the leak at all. Then we walked out and looked at the leak detector and it was gone. So we figured it was just a nuisance trip. You know, something happened with the sensor. So he left. Came back a week later, had a call. Went back in there, looked at the evaporator, leak tested the hell out of it. Couldn't find it. He said, you know what? It must be the leak detector sensor in the cooler that's bad. So he changes it out, the leak goes away. 2 weeks later, he gets a call. Leak in the cooler. He goes back in, cuts the evaporator out, caps it, puts nitrogen in it, can't find the leak, calls Parasense. Parasense comes out, that's the leak detector company. They say, we're good, you have a leak. No, we don't have a leak, you have a bad sensor. This whole argument goes on for 2 months. 2 months. And then the mechanic that got the original call happened to be in the cooler. Looking around, does anybody have, and this was out in Seattle, does anybody know how you ship halibut from Alaska?
Dry ice.
And what was going on? The dry ice was sublimating. The leak detector doesn't know the difference between a solid sublimating, me breathing on it, or too many people. Well, that's not true. That's another misconception. But understand, you gotta think dry ice. There's a grocery store in the Southeast, Publix. You know how you ship sushi? From the sushi factory? You pack it in. They had so many nuisance trips, and I've been telling them this, and Paul had been telling them this, that they actually put a sticker, big red sticker on the cooler and freezer that says, do not store dry ice in the coolers. They actually take it out. And they won't even put it in the back room now because they get so many calls. In the produce department, or produce prep, guess what happens when you cut pineapple? It respirates what? CO2. So it can actually set your leak detector off. There's certain green lettuces in the produce department that will produce CO2. So you just have to understand that it's not something I got to be worried about, but it is something that I have to be cognizant of. All right? So as things sublimate. But remember, dry ice is not that big a deal if you handle it. Case controllers. Now, if you were to ask me about booster systems, CO2 booster systems, this is the problem. This is what's making it complicated. CO2 is easy. Kind of like, if you really want to be confused about case controllers, come to my class later. There's about 8 of them right now. And one mechanic may go to one and have 3 different case controllers in one store. You may have 679s. You may have the CC200. You may have the microthermo, all in the same store. Modbus, BATMAT. That's what's making this complicated, not the CO2, but we have to understand, there's a Danfoss 550. This is a great controller, by the way. Case controller, oh man, I love this one. So since I love it so much, you know what happened to it? It's obsolete. Of course, anything I like, they obsolete. So now I have to learn a Bluetooth 55. But you're gonna find yourself more challenged on case controllers than you are on CO2 itself. But I have to have case controllers because I have to use an electronic expansion valve. There is one mechanical valve out there that nobody wants to use, the new Danfoss valve. But since they don't use it, I have to learn that. As a mechanic, I have to understand it. That's why I now own an oscilloscope. And I'll show you the video that if we get time, how we're going to troubleshoot electronics. That's complicated. That's what makes this hard. Has nothing to do. These are just different case controllers we go through. All right, so there's Pikachu. All right, so everybody understands what I'm saying with case controllers, yes? Electronic expansion valves have to be controlled with their own controller at the right. Then they've got to be connected Modbus or with a communication line up to the controller. The controller has to see it, not to work, just so everybody can call their monitoring company, and the monitoring company can collect data and tell me how much energy I'm using, or if I have a leak. So these are things I have to understand. So as a mechanic, I've had to invest in Pikachu. You see Pikachu right here? Yeah. Yes? How many people have one of those? No? $140 on Amazon. I plug it into my computer, I hook it up to a network, because I said it was a little more complex, right? So if something gets a little harder, what do we have to do as mechanics? We have to do what? We have to adapt. We have to get smarter. Not only us, but our what has to get smarter. Our tools have to get smarter. I have to understand how to Bluetooth into a CC200 or 55. I have to understand. You know, I always say, I love, people go, with controllers I have graphs, yay. But if you don't know how to read the graph, what good does it do you? So as a mechanic, that's my challenge. How do I read a graph? What does the data tell me? It doesn't do me any good to have data if I can't interpolate it. I can't understand it. I can't see what it tells me. So here's an example of an oscilloscope on a Modbus Corel system. Oh, I forgot to put the video in. So when I have this, I simply get a video and I can see the DC signal that runs across the Modbus line. Yes? And if I got a beautiful square wave, yoo-hoo, I'm good. Next class? Yeah. No. And so, what was that? Oh, so if I look at it here. Did you see how quick I went there? Where am I at again? But so this oscilloscope, dude, I'm telling you, this is the way you troubleshoot case controller. Let's take the complicated and make it what? Simple. Let's break it into small bites so that we can understand it. So if I'm going to do CO2, if I have to have case controllers, okay. How many people remember the old days how we're doing it now? Everybody knows, so unless you know what I'm talking about offline case controllers, yeah. And how many people sit there with a case controller, you're talking to somebody on the phone, he's at the rack, at the E2, looking at what's online, and you're like, all right, no, I just plugged it in. No, I ain't plugged, what, that one's off, let me plug that. No, it's good. That one's good? No, it's refreshing? Oh, refresh. Right? And I wore myself out 2 or 3 days trying to find something, walking every single controller, making sure the wires are cross polarity, or I've got just one strand of the negative terminal touching the positive, my whole network goes out. The case that I'm working on is working fine, it's the one downstream that's off. Can I get an amen?
Amen.
Is that a pain? Yeah. And so the easiest way to do it, you see that, can you see the square wave I have there? And if you notice, that square wave will be moving at the same rate that that little TX and RX light is flashing. And so I know I'm stop, send about the signal, stop, send signals. Well, if that signal doesn't look like that, or if it gets smaller and shrunken, it just doesn't look like a beautiful square wave, what's going on in my network? I don't know yet, but it's going to help me. If I see noise, a bunch of buzz coming off my signal, I'm probably running too close to the ballast or the baler or some kind of induction or the inverter. Yes? So what I did, who was talking about one action? So we had a Winco, we had a lineup, we came back after we got it started, we had a lineup of 40 cases. 40 cases. And they were constantly going offline. Wade Schatz and I go in there. Wade had never seen Pikachu, he heard me talk about him. He goes, you got Pikachu with you? I said, yes I do. He said, it's Pokeball. Opened his Pokeball up, we got him out, hooked him up. I went upstairs, hooked him up, made Wade go to the cases. All right, so here with me.
Is Wade here?
Wade.
Oh, Wade.
Wade Schatz. He's retired. He doesn't have to do this anymore. But we went up there. All right, so you guys tell me, you guys are some seasoned mechanics. So I hooked Pikachu up, and the signal's horrible. You have 40 cases on that network. What would you do? What's your first step to find the problem? 40 cases online. That's a lot of cases to try to find a mod bug, yes? What would be your first fix?
Find the midpoint.
And do what?
And break it, then start.
So we went to case 20. We took 21 through 40 off. Boom! Signal's perfect. What did we just do? What did we just knock out?
After work.
Half of the cases are good. Case 1 through 20 are good. So now what do?
Continue on if it worked.
What's that?
Continue on if it worked. So back yourself up. If it worked, if it didn't work, you gotta start cutting them down.
So I got 1 through 20 good, so I'm going to add what? We added 5 more.
One drops out, you actually problem in there.
What's that?
One drops out, that's when it drops out, that's 1 to 5.
So we went, and I'm not going one at a time, I'm too lazy for that. So I went to 25. Good, disconnected. You know, now we have 25 cases on the network and the signal goes down. So where's the problem? 20 through 25. So we looked at it, and 23 happened to be a coffin case, where everything else was open cases. So who are you going to bet money on? The coffin that went from here down through conduit, underground, back up to 24, and hit 24. So we went, all right, we went to 22, took off 23 through 40, perfect. We added 23, we went down to 23, took 24 off, signal was good. Up to 23, and the COM board on 23 was good. Where's our problem? We went back, we took a wire, ran it from 23 to 24, on top of the cases, got in everybody's way. Signal was perfect. What's the problem? The wire in conduit that went from 23 to 24 had an open. I think it was broken, it was kind of touching the way the signal looked. You know how long that took us to find a wire in conduit underground? You know how long that took us?
40 minutes.
No, 40 minutes. You wanted it to happen in 4 days. But how long would that have taken without an oscilloscope?
4 days.
4 days.
I know.
So as systems add on, as we get more and more complex, be it the high pressure control valve, learning how to take it to manual, how to buy a little signal generator to send a 0 to 10 volt signal, or troubleshooting an off-site network. As we continue with CO2 and as we move forward, we must get better with our what? Our tools. We must get smarter. Don't you love the fact that we're running out of mechanics anyway, and all we've done is complicate stuff to make it harder? Yay, we all need a raise. Everybody here needs a raise. No, I thought I'd get a better response from that. Is it a leak? What is my time? Am I good? What time do I go to 8:30? 9 o'clock. Oh, damn, I've never been done early before.
Still not
Because of
done
all
yet.
this conversation we're having so far. All right. So, is it a leak or is it a vent? This is something, this is a big question, right?
You let me away with that?
What sucks is that we just all stop and watch it. How uncomfortable is that? I feel bad for him. All right. What was that? Oh, is it a leak or is it an event? Does everybody know what I'm saying when I say this?
Is it seeping or is it blowing?
What's that?
Is it seeping or is it blowing?
Not blowing, blue. Let's keep our vocabulary.
Okay, I'm sorry.
Because one thing about CO2, at some point, am I gonna lose some gas?
Yeah.
Okay. That's a fact. I could say that's not true, but you know it is. I'm going to lose CO2. But what's happening, and it's for a variety of reasons, right? Maybe I've had something shut down, high pressure control valve. I've had something shut down and I'm trying to maintain a pressure. These are regulating relief valves. But what we're doing is once we add gas, we're recording it as a leak. And so now the impression is that we have leaky systems, yes or no? And so we have to understand, do we have a leak or did we have an event? And an event is when I have a release. Top up. One of my relief valves gone up. So I have this one. What's that?
You're still all right? Comfortable?
I'm good.
Yeah.
I'm the only one moving, they're sleeping.
Well, last time you were here, you sweat everybody out, so.
I think we're good, temperature wise. Anybody know anything about air conditioning, if we need it? Air conditioning? No, I don't do air conditioning.
Pretty cold.
How bougie is that? No, I don't do air conditioning. So, I'm gonna have these relief valves. I have one at 30 bar on the low temp suction. I have a 45 on medium temp suction. I have a 120 bar on the discharge line, 1720, right? So, and then I have two on the vessel. One at 45 bar, 650, one at 60 bar, 882. 882 is for servicing. So I have to understand all of them come into a manifold of some form, and they're all going to release outside. So if I have a rack, so I get questions all. Yes, per man. Yes, per man. So the one thing I tell people, how would you know? How would you know if you had a release of gas versus before you start? Because before I leak tests, and by the way, I absolutely hate leak checking. It's the bane of my existence. I hate it. I'm the guy that finds the Schrader cap with the O-ring missing, which means I don't want to look for a leak, and I'm just going to find a leaky needle valve. That's me. I'm the one that writes that on his ticket. So I absolutely hate leak checking. And so before I go, if I were on this site, before I started looking for a leak, I would simply look to make sure it wasn't a what? Pop-up, an event. That's what we call that, an event. How would I do that? How would I know? What's the quickest way for me to tell? What is it?
Oil, signs of oil or a leak detector.
So the leak detector, but the easiest way on these relief valves, simply look for oil. Because the gas is going to take what with it? Oil. And so if I see oil, which one went? I have a whole manifold. How do I know which one went?
Take them all
Okay. Another thing about me, I'm incredibly lazy. And that's way too much work. And that's a good way the first time, because once it pops, it will always be oily. Yeah, unfortunately. There's this thing. I don't know if you guys have ever heard of this. It's kind of new. It's kind of, what do they call it? A rack controller. No, nothing? An E2, an 880, a Dan Foster, 782, microthermal, whatever. What does my controllers grab? Suction pressure, low temp, suction pressure, medium temp, vessel pressure, discharge line pressure, yes, where all my relief valves are. So if I saw oil under there, I'd simply go where? Or if I'm older, I'd get a kid to do it for me. Sorry. I would simply go and look at my graphs, and when I saw something go like this, and then what happens once you hit the relief point? What happens to the graph? Like this? There's my culprit. Now I know, was it a one-time event? Did something just happen? Somebody shut something off and it happened once? Or am I cycling my system on one of the relief valves? Do I have a more in-depth problem? And that's going to help me separate. And if I don't have any roulette vents, then I get my what? I get my leak detector out. I get my Infocon Stratus, put my CO2 charge in there, and off I go. Me personally, I'm going to call one of the apprentices and have them do it. But, so, what was I?
Apprentice.
All right, so I simply go to my graphs, and if it's not that complicated, it's easy. Use the controller you have. Understand what is a leak and what happened because something closed, a valve failed, and I have to understand that. What was the event versus the leak? And we really, really, really need to start focusing on that. And we really need to start putting on our invoices, if it were a leak or an event, so that we can track it better. Because the whole industry right now, that's one of the things we talk about, is it a leak? Is these are CO2 leaky systems? Or do I have events? And if we don't track it, we mechanics, we're the frontline guys, yes or no? We're the frontline guys. We're the ones giving people data to make decisions. So make sure you're recording on your invoice, is it an event or is it a leak? If it's an event, tell me what it was and where it was at, just so I can keep the data. All right? Anybody know what that's for? That's something else is something. I hear people talk a lot about CO2. Kick off prematurely on high head. Remember, these systems, you do have to vent them for non-connectables. You have that part of your PMs. That could be part of your regular service call. Pump the rack down. Make sure you don't have non-connectables because you used the wrong, you didn't purge your hoses before you opened it to the system. All right? You like that?
That's awesome.
See that? That's a vent line from the manifold that they put in. That's pretty cool. I like this one.
That's what
Back to shower.
You know, in some counties though, that's code.
It's not that high.
What county is that?
I've seen, if that's, if you live in that county and that's code, you better move. So, I train contractors constantly, but a lot of times I like to go out the day before and look at the system before I teach it. This was one of those events. I took this picture, I went down and popped the next day, I popped this up, and I could tell immediately who the mechanic who did that was, because he's the one that was going like this. Bro, really? The next day when I showed up for the online, the in-house training, or on-site training, this was gone. Does everybody see how this is ridiculous? Can you imagine the people living right behind this store? There's a house right here with a clothesline pole.
Hey, birdhouse.
If that blows off, tell me some of the things that's gonna happen if that blows off. What kind of motor do I have in that condenser, gas cooler? EC motors. Tell me something about EC motors. High dollar. I just blew oil all over those EC motors. Plus the poor people living behind that are sitting there hanging their clothes on the clothesline pole going, yeah, I didn't know it was supposed to be oily today. I'm like, dude, that little common sense is something we need to start teaching. Because obviously it's not around. I don't know. CO2 tanks. All right, so there's a big controversy here, a big conversation about the tanks versus the gas. Am I running out of gas, which we did for a little bit, or am I running out of tanks? So remember that. And remember, let me tell you a quick story about something that happened in a store in the southeast, a store in rural Alabama. So, first of all, remember rural Alabama. They had a component break, system dumped, lost the charge. Now, of course, the mechanic didn't get the call until cases were running warm, which means he's basically out of gas now. Shows up on Saturday morning, about 2-ish in the morning, of course, per law, and he has no CO2. They don't have CO2 in the store. It's in rural Alabama. They don't know where to get CO2. Calls the service manager. Service manager doesn't know. Calls the coordinator. Coordinator doesn't know where to get CO2. 3 hours later, they find some in Birmingham, Alabama. They take 2 vans, because these tanks are very heavy, two vans to Birmingham, 3-hour drive. Then they got to come back from Birmingham. There's 6 hours. Rock's already was down. So what are we at now? 9 hours? They get back, they find out nobody in the shop knows how to charge a CO2 system. Now the rack is down, nobody knows how to charge it. They got to call the coordinator that lives in Pensacola. That's 2 hours away. He has to drive up from Pensacola. He gets up, shows them how to charge it. End of story. The rack is down for 23 hours. Amen? How's the product doing? Try to get refrigerated trucks to rule Alabama in the middle of the night. Not happening. So the moral of the story is,
Keep that on the
we got to know where to get the gas, yes? When do we figure that out? At Saturday at 2 in the morning? Or do we figure that out at 8 o'clock on Monday?
8 o'clock Monday.
Understand where to get gas. It's not at United until they start holding it. They're still not selling it. Some little Uniteds will keep it, but know where to get it. What air gas place am I getting? Where can I get Coleman grade? Can I use industrial grade? Yes, by the way. But you must understand what gas you get and where to get it. Does that make sense to everybody? Because it's not a regular, I'm not keeping it at United. It's such a cheap gas. United can make more money in that real estate selling filters than they can CO2.
welding supplies.
What's that?
Welding supplies.
Yeah, the welding supply, that's where you get liquid air or air gas fluid. And they can get industrial grade. And so you can get different grades of CO2. Most manufacturers say Coleman grade, the 99.99%. But if I'm about to lose a rack and I have industrial grade,
Going in.
I'm gonna run through a dryer on my hoses, and run it through an HH, and do a non-condensable test when I'm done. All right, these just show some of the different liquid tanks. Everybody knows, oh,
Give it away.
you're gonna love this group. I was in South Carolina, showed up the day before. Paul and I were there. Yes, check this new grade out. This is a new grade of CO2. I see this grade all the time. People don't think about this when they're thinking about CO2. That's the MT grade.
The beverage grade?
MT.
Empty.
How much gas do they have in the store?
Zero.
None. And they're doing a remodel. You have to laugh. Some things you just have to laugh at. They have no gas and they're going through a remodel on CO2. So we gotta make sure we understand that I can't get the gas like you can 404, 22 or 450 or 448, 449. I have to understand where to get it. I have to be prepared and I have to know where it is. Servicing the summer. This is one of the biggest myths that I've heard. And I hear this all the time. So what I'm gonna do is there's some call lesson for a lesson learner. And I'm gonna change this. And I have two vent valves on there, one at 45 bar, one at 60, one at 650, one at 880 pounds. All right, so, and there I am switching it. I'm just gonna go through this call to show you that that's a bunch of, gotta watch my mouth. It's not true. So there was a rack in Atlanta, Georgia, and I was asked to come help them do some PMs. It was June, and I decided, you know what, we're gonna do this in June on a roof, 104 on the ground, Atlanta. And we thought, you know what, I'm gonna time it just to see how long it takes us before we start losing CO2. Is that good? Is everybody good with me? So this is what we have to think about, because I hear this all the time. I hear people go, oh, I got hot, we lost all the gas. I'm not pumping it down in the middle of the summer. So we took it down, we closed the liquid line ball valve. It was 104 on the ground, white roof in Atlanta, Georgia, June. We pumped the rack down at 10:30, quick, start the timer. Right, we had it on the phone. First thing we did is we switched, from 45 bar, which is normal operation, 650. We simply took that relief valve and switched it to where?
60 bar.
The 60 bar, the 880. What did that give us more of?
Time.
Gives us more time to work, yes?
Yes.
Has more time to work. And so we pumped it down, we switched it over. Then here's where you have to start thinking differently. This had an adiabatic gas cooler condenser. Well, let me ask this question first. If I close the ball valve, and pump the rack down, I've separated the store from the rack. So what happens in the rack doesn't happen in the store. Did I just create a tank of gas? Condenser and receiver and all that, just one tank of gas, yes? In essence, all the same pressure. So we simply turn the water on the adiabatic pads, yes? Turn the fans on the condenser. What did I just give myself more? Time, because that cool air, even though it's hot, it's going through that water, and it gives me more cooling of that gas and gives me more time. That's what I want, because I don't want to relief on those relief valves, yes? I'm trying to avoid that. And so then we start doing our work. Now, we want to be prepared. So we put a hose on the flash tank, on an access port. So if we got close to relieving valves, we could simply do what? Vent the gas more and control the vent instead of letting the relief valve go. You see what I'm saying? So now I'm watching it with one eye. So if I saw it get to about 820, so I'm not that brave, I would have simply vented it, and what would happen with the pressure in the receiver? It would have went down, giving me more time. And so we did all the PMs. We changed the high pressure control valve, programmed it, we changed the coalescent filter, changed all the oil filters. But one of the things we did before we started our work is we started planning, thinking about our work. One thing we have to do now when we're doing these different gases, the one thing I don't want to do is once I take this rack down, I don't want to have to go where?
What do I do?
What's that?
What do I do?
What do I do and go down to the what? Downstairs.
Firehouse.
Or, yeah, if we gotta go to the supply house, we got issues. I'm smacking somewhere, right? I don't even wanna go to the van. Oh, dude, I forgot the vacuum pump. We just did this in New York, thank God it was winter. I told them 4 times, get a vacuum pump. We got down, they go, oh, we don't have a vacuum pump. I'm not going down and get it, right? But so we made sure we visualized our work, we walked through each step of what we were doing through our service calls. Does that make sense? This is where you get away from this stuff where they say, oh, I lost gas in 20 minutes. Oh, I lost gas after 3 hours. No, you didn't. Be prepared, understand what you're doing. So long story short, by the time we took everything down, did all the service work, pulled our vacuum, it was a larger, so we did 4 cigarette vacuum. And once we pulled all that down, we were down at 10:30. We came up at 3:45, 104 at 10:30. So God knows what it is now on that white roof. Yes? You know how much gas we lost? Nearly once. We didn't lose any. Because we were paying it. Now, I'll be honest with you.
Yeah.
When we came back up, we were right at that point. I looked at the date and we're right at 8:50. So if we were gonna go 5 more minutes, we would have done what? We would have done some gas. Right? So when you hear people say these rats can't work in the South, they can't work, you can't service them. I did it in Atlanta, Georgia, where the RH is what in the summer?
95.
It's 100%. There's 100 degrees with 120-degree RH, right? So if I can do it there, I can do it in California, where your RH is what, 30 on a bad day. I couldn't live here with that hot, dry climate. All right, so is everybody good with what I'm saying here? So every time we talk about it, you hear somebody say, oh, with CO2, this is what happens. No. There's a solution for that. We just have to understand it. All right, one of the other things I'd like to talk about, let's see what else I have here. Yeah, we turn on the 80 watt condensers. You can turn on your fans. Charging through the evaporator. How many people have seen this on the internet? Evil. If you're getting your service tips off of a social media tip, stop it. There is stuff, and then there may have been Paul that sent me that, but I'm on zero social media. What's that?
My supervisor told me to go there and look at it.
See what's a TED Talk? Send me an email before you do it. Because there's so much stuff I see, and here's one I see a lot. I've heard, and it's on the internet. It has to be true. So somebody posted on the line on the internet on this. I think you're the one that said it, right? Or somebody said it to us. Somebody online said that they are charging CO2 through the evaporator, through the low temperature cases, or medium temp cases. Is everybody with me? Alright, so let's talk about that. I'm not going to, well, I'm going to tell you right now, you're going to avoid the warranty, and I don't care who the manufacturer is, because our coils are rated at 650. Amen?
Yeah, because it's on your.
Alright, so let's go through this. My copper line, Pure Mueller, I grabbed this off their site. They rate their pressure, their ACR, L&K copper, which is what I have in the grocery store. That is rated at, oops, click the button. It is rated at 700 PSI. Are we good? So, this is the guy from, and I don't call out contractors. I'm not going to tell you who the contractor is. So don't ask me. See hope. So here is what we found. This is a picture I took in the store. That is a gas of CO2.
How long did it take to charge like that?
That's pretty quick for a while. So he fills the store. So let's just look at the numbers. The coil's rated at what? What did I say the coil was rated at? 650, yes? What did we say the pipe was rated at? 700. 75 degrees inside this store that we're at right now. 900 pounds of pressure in that tank. I have a charging line in my store that goes up to the roof that I can simply hook my tank up to, yes? I can use my manifolds up there for 10A gauges, or if you have CO2 gauges, I can charge it into the receiver, which is going to run somewhere in about the 35 degree range. 515, 520, 525 range. 900 pounds. I have plenty of pressure drop, yes? The only reason you're doing this is because, I'm going to say it, because you are what? Lazy, like me. You are lazy. I'm sorry. It's you have 400 pounds of pressure drop. He's now exceeding the pressure drop or the pressure of that coil, yes or no? I told the dude, I said, dude, you know you just avoided the warranty. I'm saying. Because I don't trust any case you do that. Amen? So I ask you, I want to be fair and honest to people if I can. So I said, bro, what are you doing? And he goes, no, it's fine. Oh, okay, I gotta hear this. Why is it fine? You don't understand. You see that handle right there? No, what I'm doing is I'm metering the gas in. Okay, let's stop. What if my man, because we do this with 404 and all our other refrigerants all day long. I've done that, I don't know how many times. We all do it because my pressure is lower than my evaporator. No big deal. But my man is thinking what? When he says he's metering, what's the state of the gas he thinks he's metering? Liquid. He thinks he's worried about the compressor. Dude, you're going through a quarter-inch hose, so we're good. But he's worried about liquid. He's not thinking about what? Because once he cracks, I don't care if you open it or if you crack it, what type of pressure is going into there? Tank pressure. Yeah? 900 pounds. And I'm like, dude. And I've caught 2. Bobby said he's caught 4. Have you caught any?
Yeah, it's the same crew.
Yeah.
And then they called me up and asked me if it was okay.
Yeah, and I'm like, no. But does everybody understand some of these things that we have to understand? We said we have to understand pressure. It's pretty simple. I believe for me.
What's on the other side of that hose?
Yeah, that's the other fun thing. Do you see where he's putting it in? You see what that is? That's a 650-pound transducer. Yeah.
He didn't hit it with liquid CO2.
And he's hitting it with 900 pounds of liquid. So how good is the super reading coming off that transducer? Not good, right? And so these are things, so when I hear people, I kind of get irritated when I hear people talk about how bad or how dangerous or all of these things the CO2 is. I just gotta tell you, we have to just understand our equipment, understand what we're looking at. I don't care who the manufacturer is. We have to take our time, understand the equipment, be trained, and then go on from there, yes? And then remember, we still have to have superheat. I still have to have subcooling. I still can't put liquid into my compressor. All the things I can't do, I still can't do. I can't shut up. It's CO2. Can I continue to add oil into the oil reservoir if it's CO2? How many people read that in the logbook? Added a gallon of oil. 2 weeks later, added a gallon of oil. 3 weeks later, added 2.5 gallons of oil. Where the hell did that other half a gallon go, right? December 25th, took out 15 gallons of oil. It's still true with CO2. Pump it down. Pump it down before you ever add oil. If you're not adding refrigerant, I didn't say CO2, did I? If you're not adding refrigerant, you're not adding what? Oil. Oil somewhere, probably an evaporator. Pump it down. I like to do twice. Bring your oil back. Yes? So keep that in mind. And then if I'm charging CO2, I simply have a charging port. I have it at 500. I have an access port on top. I put vapor in my charging line here. I can put liquid in my receiver here. My receiver is going to be running around somewhere around 35 degrees. 35 degrees, around 550, anywhere from 500 to 525, depends on manufacturer. Right? Not enough trained technicians. Unfortunately, this is not a myth. This is a reality that we live with. Yes or no?
Yes.
Does anybody have a younger brother? A cousin? Anybody that's getting out of jail soon? We take all. We need more people. If you have any friends that have just gotten out of the military, send us some vets. You're an Army vet? I'm like, send us these people. Hey man, we need more people. Because otherwise this trade is going to go away, and I'm going to be on my deathbed, and there's no, we're using salt for our meat again. And I just won't die.
Is that right?
I can do that. Or I can get water out of the ocean. Now, there are different, Kaiser Warren, they have a training facility. And 2 of them, one in Georgia, one here in California. Hill Phoenix has got a learning center where they're going around and training. They've got 2 trainers going around the country, training all the different contractors. NASRC, I travel constantly. We're out here training with a lot of contractors, school systems, a lot of you different contractors are setting up training programs, yes? That boss has some training. YouTube sometimes.
That's you for YouTube. Right next to you, John.
Hey, and if you see it, and if you're online and you see something that doesn't make sense, send it to me. Let me look at it, because it's probably not right. You gotta be careful. But we need to get these guys trained. If you're a seasoned mechanic and you've never worked on CO2, should you go through training before you close that valve? I promise you, the first time you go up on a roof on a CO2 in the middle of the night by yourself, that's a high pucker fact. I promise you. And if you need to call me, I will give you a hug, a virtual hug. It's okay. Breathe. It's okay. But we need to get more guys trained. We need to open it up to women. We need to open it up to everybody through the union halls, through the tech schools, just our own apprenticeship program. But this is more and more important, and we got to get out there and we got to train these people, because that unfortunately is not a myth. We have to have both classroom training. Remember, you can't teach somebody CO2 on site only. There's things I have to know on paper. I have to know the high pressure control valve. And he's gonna do a good job of that. I gotta understand the oil system. It's a little different. I gotta understand this on paper. Does everybody understand what I'm saying? I have to understand the vocabulary. I have to understand on paper. Then I have to go out on the rack. Or I have to go to some of the different manufacturers who have in the school, right? So I'm just saying let's make sure we're doing that. And the hands-on is very, very important. I already covered this one at Walmart. Never enough time for training. How many people agree with that? Man, I show up someplace. I know Paul's showing up. We're gonna have everybody there.
And no one's there.
And then 2 apprentices show up. Dude, how long you been here training? I just bought my first set of gaugers yesterday. Now you're starting to bleed. Where's the other guys? They don't call. What? Sometimes to move forward, we have to have a pause. Yes or no?
Yes, sir.
And how many people say sending somebody untrained on one of these is bad news? How many people say it can be dangerous? Dude, I love walking. I actually had an apprentice one time. We were training, and the rack was running. It was summer. We were in Rhode Island. We were running about 1,120 pounds. Had an apprentice. The whole time in class, just sitting there. He's probably a second year. He's sitting there just in that Rhode Island store. And so we go out the next day to the class. He's standing here against the wall. The rack is over here. And I said, kid, come here. Touch this discharge line. No, come over here, kid. Refuse to come anywhere near the rack. But what I love about refrigeration people, my people, is we're so sensitive to one another. We are the most sensitive group of people to young people. That's how we roll. So this colleague picked him up, grabbed him, and put his hand on the discharge on the head. I'm like, yo, man, that's enough. I don't need it medium rare. But we got to get used to this, yes? How many people scuba dive? What's the pressure that takes on your back? How many people drive a forklift? What's the hydraulic pressure in a rubber hose with a compression fitting on that forklift when you're lifting a skid of compression? Over 5,000 pounds of pressure. It's not that big. In the South, you know what we do for fun? We give our children CO2 paintball guns. Let them shoot themselves. Yes? Yeah. So anybody from the South that says they're afraid of CO2 pressure, I'm going, boy, I'm going to tell you your mama. Because that ain't how we roll. If there's not enough, and here's the cost. Here's the cost. You see what that oil tank says? You see how it says 32? That's what we use on HFCs. We use 85. We use 85 viscosity on CO2. Now, we had another thing happen with the hot gas, but the dude, I actually sent one of my trainers to this store to do training, and like a year and a half later, and it happened to be, he didn't know the contractor was the one that did this. And so he pops his picture up. Sometimes you have to teach your youngins by letting them get beat up, yes? And so they taught, he goes, that's not true. Those tanks are empty. We just brought them up to the rack. Empty. And poor young Mr. Cody, being young and wanting to bleed people, went, oh, okay. Calls me, no, they didn't put it in. Those were empty cans they took up to the top of the roof.
For
I said,
changing the oil
say that slowly to yourself, right? Quit being so naive, dude. I know you're young, but that happened. If the heads look like that, what do you think the bottom valve plates look like? Good? You know when Husband got training for, they put this in without training. They did it without Paul or any of Hill Phoenix's CO2 specialists in the CO2 rock, right? They put this in. Guess when they got training? A year and a half after the store started. We gotta stop that. If you schedule for training, guess what I want you to do? Suck it up and go to training. If you're going to that, they got a NASRC running here in Anaheim. Hill Phoenix has got equipment out. They'll take you on site. Kaiser Warren, Zero Zone AD has class. NASRC, I'll be glad to come out, right? If you take my class, so there is a written test designed to make you fail. That's how I roll. I'm the emperor of everything I see. But you have to fail in these tests. You have to take this to understand. Otherwise, who are you cheating? You're cheating your customer. You're cheating the industry. If you allow this to fail, you're cheating the entire. How about this? How about this for hyperbolic? You're cheating your grandchildren out of a future. No? Because the planet's getting warmer. There's no doubt. I'll give you red or blue. So we got to get good at this so we can do this. All right? Isn't that good? One thing about the new equipment, we got more electronics. Have you ever heard the expression, nothing lasts longer than a temporary fix? You love these beautiful, they don't look beautiful. They got green, 24 volts, red, 110, all these oil relays. Oh, what did I do? Oh, damn it. Oh, this is working. I gotta show you this. This is incredible. Hold on. I can't believe I messed that up. Check this out. Oh, where'd it go? How's that?
There you go. That's forever. You're right.
How many people? That sure was creative. I asked the dude, how long has it been like this? Oh, another way. You know how I knew who did it? Because we had 20 techs standing in front of that open electrical panel, and guess what one of them did? Bro, you? Maybe. You have video? No. But this is a case of what? Not being, because if you look at the wiring diagram, he thought he jumped out one relay. He jumped out 3 safeties because there's 3 safeties before that are going to trip that. It's going to take the rack down and send an alarm to the Novar control. Oops, my bad. He's going to send the alarm, and he bypassed a high pressure vessel alarm. Does that sound bad? He was going to come back. How many of you told this lie? No, I'm going to jump about tomorrow. I'm coming back to fix it. Liar, you are not. 6 months or 18 months. 18 months. So nothing lasts longer than a temporary fix. If you got a jumper, don't jumper it out. Carry things. If you're on call, make sure you stock up with relays. There's tons of electronics in these racks. Understand what you're looking at. Understand what to do. If you're getting out of a truck without a gauge and a meter and a 6-in-1, get back in the damn truck. It ain't doing me no good. Amen? All right, so let's keep that in mind. I don't know who put this in like this, but does anybody see a problem with this, what this cat did? He actually had to drill holes to get the compressor in to sit like that. Does that make sense? How many people love that? I'm not changing that. Everybody knows what a coalescent filter is, yes? That's my main discharge oil separator that keeps my oil clean. And I have to change it once a year. Yes or no?
Yes.
If you don't change the filters, when you change the cartridge, it's like taking your truck in and getting the oil changed and not changing out your whole filter. This is the rack that went down on oil simply because they didn't change the filters. So it says, oh, well, CO2 doesn't have that kind. Yeah, it does. Anything that I have on a regular rack, think of that. Everything I have on a regular rack exists where? On a CO2 rack. I have a couple of different valves. I have a wee bit more electronics. I have to understand my controllers. But other than that, it's just a rack. Don't let anybody tell you that, oh, the CO2 is this thing from NASA. It is not. CO2 was patented in 1850. It's an old refrigerator. Before, if you're losing oil, compressors are going down and you can't get oil, check your filter. The beautiful thing about coalescent filters is they work really, really good. You know the bad part about coalescent filters? They work really, really good. So if I don't do my PMs, now I can't maintain oil, I can't feed my reservoir, I got oil all over the place. If that breaks long enough, now I have particles in my system that's gonna plug my expansion valves. So we just have to understand, this is not new, it's not different, it's the same thing I've always worked on. I got 2 valves that I got are different. Other than that, it's just a rack, just a refrigeration rack. The store doesn't know if it's CO2 or 404. It's just a refrigerant down in the cases, moving heat. That's what I get paid to do, move heat. And so just keep that in mind, it's not that different. Any questions, comments, challenges? Oh, good.
What do you think about the lack of use of auxiliary cooling fans?
I'm glad you said that, because that's what I was gonna put
I
down.
recently spoke with a big retailer, and their thing is, well, I have to have a generator, and it's added complexity, and I just don't want to do it.
Okay.
And they've lost charge.
And they've lost standstill pressure. So let's talk about that. That's the thing I said I was gonna add that I didn't have in my presentation. Auxiliary, there's a lot of conversation now about changing the rating of the system and doing these different things. If you look at Europe, one of the reasons they're able to stay at a lower pressure, not raise it up, is it is mandatory that you have a auxiliary condensing unit. You can put these auxiliaries in. It's a small little, let's say, heat craft unit that maybe has 448 or whatever. And I operate it. If I lose power, I hit a certain pressure. I turn this little bitty unit on, this little heat craft unit on. And all it does, it has a little bitty heat exchanger, a braze plate, and it simply cools the gas. It doesn't keep the store cold. It's not designed to do that. And people who say they don't want to add a generator, remember, we've made huge advances in these new electric generators that we have out there that are good for 6 or 7 hours. That if you keep them charged like giant UPSs. And so I can simply power the little unit up. So I say to anybody who's not using an auxiliary, you just tick-tock, tick-tock. You're on the clock. Because you are going to lose power. There's going to be a tornado. There's going to be everybody's going to plug in their electric car in California. You're going to have a brownout. These things are going to happen, yes or no? And so I say anybody who doesn't put an auxiliary in,
It's done.
Yes, is CO2 stupid? Does that make sense?
Yeah.
And look at what Walmart's doing with their new skids. Every one of their skids have an auxiliary unit on a power battery generator.
So the generator runs the cash register.
They need to, well, not also. And if you have a life safety generator to run those cash registers, it's a 15 amp, 20 amp condensing unit. Throw it on there, man. You don't have to upsize that, right? Is that good? Is everybody good with that? I think anybody who doesn't put a generator, my opinion, is making a mistake. Yes, you agree?
I agree, I mean, cause there could be hundreds of thousands of dollars worth of food, and you could be in the middle of Kansas where there's no CO2 around.
No technicians. Well, you're picking on Kansas here, but that's all right.
Garden City.
I was just from Wichita. But does everybody understand what his question was, what the answer is? You've gotta put these auxiliaries on, and if you put an auxiliary on, run a test, power it up once a month or so to make sure that when you do need it. And the beautiful thing about auxiliaries, see, just for y'all, think about mechanics, is if I put a mechanical switch on it, a toggle, and I'm gonna service it, and I take it down, I just flip a toggle, I turn this little auxiliary on while I'm changing the coalescent and stuff, cooling the receiver, flash tank, and that just gave me more time. I'm never gonna lose gas if I have one of those. Just pop that little auxiliary on. Now I can take that rack down and work on it all day, and I'm good. Does that make sense to everybody? And those are one of the things everybody says, oh, it's too expensive. Oh, I don't wanna put it, it's expensive. It's too expensive. No, it's not. When you weigh food, loss of food, gas that you may or may not be able to get right away, like that store in Lower Alabama, it pays for itself. One power outage and it's paid for itself. So keep that in mind. All right? Anything else? What time are we done?
We're done.
Hit 9 o'clock?
Yep.
Woo-hoo!